data flow diagrams are DFD. A DFD is a traditional visual representation of the information flows within a system. A neat and clear DFD can depict the right amount of the system requirement graphically. It can be manual, automated, or a combination of both. It shows how data enters and leaves the system, what changes the information, and where the data is stored. So it will show how the data will enter the system and it will leave the system. The objective of a DFD is to show the scope and boundaries of the system as a whole. It may be used as a communication tool between a system analyst and any person who plays a part in the order that acts as a starting point for redesigning a system. The DFD is also called as a data flow graph or a bubble chart. The following observations about DFD are essential. All names must be unique. This makes it easier to refer to the elements in the DFD. Remember that DFD is not a flowchart. Arrows in a flowchart that represent the order of events. Arrows in a DFD represent the flowing data. So in a flowchart, the arrows will represent the order of events. Suppose I have to start. So first I will say start. Then I will say that the user will log in. So this is what? This is the flow of the programmer. But in case of a DFD, there is no flow of program. It is the flow of data. So suppose there is a library management system and there is a admin. So admin will insert the student data in the library management system, and the library management system will give the fine calculation if a student has given a book later to the admin. So it is how the data is flowing. It is a flow of data. Suppress logical decisions. If we ever have the urge to draw a diamond shaped box in a DFD, suppress that urge. Diamond is only in the case of a flowchart, not in DFD. So you have to suppress the urge of drawing a diamond in a DFD. A diamond shaped box is used in flowcharts to represent decision points with multiple existing paths of which the only one is taken. This implies an ordering of events which makes no sense in a DFD. So diamond is there for a decision pointer, but in a DFD there is nothing like decision, so it makes no sense for putting a diamond in a DFD. Do not become bogged down with details, defer error conditions and error handling until the end of analysis. Standard symbols for DFD are derived from the electric circuit diagram analysis and are shown. So data flow circle means a process source or a sink, external entity, and the data storer is represented with the arrows. Standard symbols for DFD circle. A circle shows a process that transforms data inputs into data outputs. Data flow. A curved line shows the flow of data into or out of the process or data store. Data store, a set of parallel lines showing a place for collection of data items. A data store indicates that the data is stored which can be used at a later stage or by other processes in different order. The data store can have an element or a group of elements, source or a sink. Source or a sink is an external entity that acts as a source of systems inputs or a sink of system outputs. So levels are in a data flow diagram. The DFD may be used to perform a system or a software of any level of abstraction. In fact, the DFDs may be partitioned into levels that represent increasing informational flow and functional details. Levels in a DFD are numbered as 0, 1, 2 or beyond. Here we will see primarily 3 levels in data flow diagrams, which are 0 level DFD, 1 level DFD and 2 level DFD. So in a 0 level DFD, you will have just the basic information flow. In the 1 level, you will have a expanded version. So you will expand the level 0 DFD, and in the level 2 you will further expand it. So further expanding the level 1, you get the level 2 DFD. So information and the functional details will be expanded up. So level 0 DFD. It is also known as the functional system model or a context diagram, represents the entire software requirements as a single bubble with input and output data denoted by incoming and outgoing arrows. Then the system is decomposed and described as a DFD with multiple bubbles. Part of the system represented by each of the bubbles are then decomposed and documented as more and more detailed DFDs. This process may be repeated at as many levels as necessary until the program at hand is well understood. It is essential to preserve the number of inputs and outputs between levels. This concept is called leveling by D macro. Thus, if bubble A has two inputs x1 and x2 and one output y, then the expanded DFD that represents A should have exactly two external inputs and one external output. The level 0 DFD, also called context diagram or a result management system, is shown. As the bubbles are decomposed into less and less abstract bubbles, the corresponding data flows may also be needed to be decomposed. So this is the level 0. In level 0 DFD, you will just have one bubble, that is the student result management, and you will have outgoing arrows and incoming arrows. In level 1 DFD, now the bubbles will be increased and you will have mark information, you will have report generations, student sub-choice management, student info management, user account management, and you will have a login. So you will have multiple bubbles in level 1 DFD. In level 2 DFD, the level 1 DFD will now be separated. So you will have user account maintenance system different. You will have a login page different. You will have display student info validate process differently. So level 2 will be a more expanded version of level 1. It will give each and every detail of the systems. Entity relationship diagram, ER modeling, is a data modeling method used in software engineering to produce a conceptual data model of an information system. Diagrams created using this ER modeling are called entity relationship diagrams or ER diagrams or ERDs. Purpose of a ERD: the database analysts gain a better understanding of the data to be contained in the database through the step of constructing the ERD. The ERD serves as a documentation tool. Finally, the ERD is used to connect the logical structure of the database to the users. In particular, the ERD effectively communicates the logic of the database to the users. So components of a ER diagram, we have already seen the ER diagram in the database management system. This is the same ER diagram again in software engineering also. So you have an entity. An entity can be a real world object, either animate or inanimate, that can be merely identifiable. An entity is denoted as a rectangle in the ER diagram. So here in this case your entities are department and employer. For example, in a school database, students, teachers, classes and course offered can be treated as entities. All these entities have some attributes or properties that give them their identity. Entity set. An entity set is a collection of related types of entities. An entity set may include entities with attributes sharing similar values. For example, a student set may contain all the students of a school. Likewise, a teacher set may contain all the teachers of the school from all faculties. Entity set need not be disjoint. Then you have attributes. What are the attributes? So if there is a student, the attributes will be address of that student, age of that student, ID number of that student, name of that student. All these are the attributes which are defining this particular entity student. So entities are denoted utilizing their properties known as student as attributes. All attributes have values. For example, a student entity. So what is the student? The student is a entity, and this student will have attributes age, address, ID number, name. There exists a domain or a range of values that can be assigned to the attributes. For example, a student name cannot be numeric value, it has to be alphabetical. A student age cannot be negative, etc. So name cannot be numeric, it has to be varchar, that is, it has to be character. Similarly, age cannot be varchar, it has to be numeric.